All right, so this is the practice final for Precalculus. We are on problem 29, so let's get down there.
James.
Please. Yes, thank you. All right. Oh, no, we finished problem 29. That means we are on problem number 30. All right, so I'm going to zoom in so we can actually read a little bit better. All right, so we have this piecewise function, and we know that it's differentiable, and it's differentiable at the suspect point 0. I need to figure out what A and B are, and then I'll add them and then circle one of my answers, right? So this is using the continuity test and the differentiability test. So the continuity test,
Did we finish 29?
I thought so. I think we said, yeah, it's negative 12. We got negative 12 for the coefficient. Yes, no. If not, you can watch the video. I think I explained it there. Maybe quickly, maybe it could have done better. You can ask me questions after we're done with the video, which I think we might finish today. So the continuity test states that I set the left equal to the right, and I plug in my suspect point. So e to the negative, plugging in 0, plus 2 is equal to a times 0 plus b. And then I'm going to start solving. So to do that, anything to the power of 0 is, you all will shout out, 1, yes. So there's going to be 1 plus 2, 3 on the left-hand side, b on the right-hand side. We've solved for b. How do we get a? Well, you use the differentiability test. I'll do that in a different color. So I'll call this the differentiability test, and abbreviating diff test. That means I'm going to take the derivative of the top, or the left, and the derivative of the bottom, aka the right piece. So the left piece, if I take the derivative of e house, daughter of e house is e house, exactly, e to the negative x. And then don't forget to multiply by your dinner. What is your, not your dinner, what is your inner of e house?
1.
You're doing dinner, but you're correct, you're going too fast. What is your inner? Negative x, and then the derivative of negative x is negative 1. So you're all correct, the dinner is negative 1. The derivative of 2 is a constant, it's 0, so there is the left piece, and I'm eventually going to plug in. The right piece, the derivative, is going to be what? A, yeah, exactly. So the b is a constant, so that's gone. And then x goes down to the power of 0, so it goes away, and it's just a. So this is just a. And let's go ahead and plug in 0. So when I plug in 0, that's 0. So e to the power of 0, anything to the power of 0, you will all shout out correctly this time.
1.
There it is, 1. Thank you, Gio. 1 times negative 1 is negative 1, so a is negative 1. Negative 1 plus 3 is 2. Correct answer is 2. On to number 31, unless anyone wants to hold up their hand, put on the brakes, slow down a little bit. All right, number 31. Ooh, natural log. So, and I'm taking the derivative. Derivative of natural log, you basically turn that into a slash and 1 over whatever the inner was, right? So it's going to be 1 all over, 1 over again, x squared minus 1. And another way of thinking about that, by the way, this is only doubter. We still have to do dinner. I haven't done dinner yet. I'm purely talking about doubter. If I'm doing doubter, I'm really essentially writing, and I'm doing this in my scratch work, 1 divided by 1 over x squared minus 1. I think we can all nod our heads. That's basically the same thing that we were doing right there. Uh-oh, we're not nodding our heads.
Yeah.
We're all okay with that step? And when I have dividing by a fraction, I keep, change, flip. So keep, change, flip it, x squared minus 1. 1 times anything is that anything. So this green thing really evaluates to just that x squared minus 1. So I'll write that on the next step. But let's go ahead and multiply by the dinner now. So the inner was 1 over x squared minus 1. Ugh, gross fraction. What do we do with it? How do we get rid of that gross fraction?
You
Take out the fraction by
doing the powers to the negative power.
negative powers. That's exactly right. So x squared minus 1 to the negative 1. That whole thing to the negative 1. That is, okay, I should be careful here. That's the inner. I haven't taken the derivative yet. So let me put a note and just say that this, bring back my pen. This right here is the same thing as the fraction. I shouldn't just point to the bottom. The whole fraction is this negative power. So now that I've gotten rid of the fraction by using negative powers, I can take the derivative of that inner. This is the inner. So take the derivative of this. My most outer house is...
Wait. Negative 1. Wait.
What house am I in?
Powerhouse.
Powerhouse. So that 1, negative 1 comes down in front.
Negative.
And then in parentheses.
X2 plus 1.
All to the power of...
Negative 2.
Negative 2. Perfect. So that was my dinner, but I haven't touched the x squared minus 1 yet. So that's my inner. I need to take the derivative of that inner to find my dinner. What is the derivative of x squared minus 1?
2x.
2x, there it is. So I have my doubter, my dinner inner. All three of them are multiplied by each other. So simplifying a little bit, this is now equal to, remember, this guy is the same thing as this guy. So I really have x squared minus 1. That is all being multiplied by, this is going to be on the bottom, and that negative is going to come out front. So let me move my, I thought I hit escape. I'm going to move my negative out front. So my negative out front, this is really going to be divided by x squared minus 1 to the power of 2 on the bottom. And I still need to multiply by 2x, so that's going to go on the top by 2x. Things are going to start canceling out. How many of these x squared minus 1s do I have on the top? 1. How many do I have on the bottom? 2. Well, let's cross off 1 on the top, 1 on the bottom, and now my new equation becomes negative 2x all over x squared minus 1. And where is that? There it's b. All right, I'm moving on to 32 unless someone wants to get a little bit more time on this one, but no hands are being raised, which means I'm on to number 32. All right, so we have this table above. Let's zoom out so I can see. Yeah, that's the whole thing. Okay, so
I hate this question.
tables are hard, and they're always on the AP test, so you'll eventually see these next year.
I'll just guess 16 or something like that.
I always guess 16. That's not the best strategy, Gio.
Claire always gets 2, and it's been right like
Twice?
questions in a row.
Okay, so I have this function h. H is equal to a function times a function, and I need to find the derivative of h. So essentially, I'm going to say that is my 1, that is my 2. I'm multiplying two functions together, therefore I'm using the what rule? The
Quotient.
It's a product rule. Product means times, quotient means divide. And Gio is already starting to write the formula, but I want to test Chris because he's forgotten multiple times before. So Chris, what is the product rule? 1. Nope. 1d2 plus. There it is. Thank you. And then I just do that, right? So 1 is, I'm just writing 2f of x plus 3. That was all of 1. Then I multiply that by d2. So the derivative of the second function, well, the derivative of 1 is 0, so don't worry about it. The derivative of g is just g prime. So this is times g prime of x. That was 1d2. Now I'm going to add 2. So 2 is just this 1 plus g of x, 1 plus g of x. And then d1, I'm going to multiply by the derivative of 1. So multiply by the derivative of this thing. So the derivative of 2f of x is 2f prime of x. And then the derivative of 3 is a constant. Derivative of a constant is always 0, so that's gone. And there is my new function. Now, what is the x value that I'm plugging in? It tells you right here. I'm plugging in
1.
1. Yes, exactly. So you can basically
Wait,
just
are you plugging for
all of the x's. Anywhere where you see an x, change it to a 1. That's a 1. That's a 1. That's a 1. That's a 1. And maybe you don't like writing it over it. Maybe you want to write it above it.
I thought you plugged in like in the table.
We're not using the table yet. I'm purely just doing h prime of 1. I have now, my new equation is 2f of 1 plus 3 times g prime of 1 plus 1 plus g of 1 times 2f prime of 1. But now I ask myself, well, what is f of 1? And that's where I use my table. When I plug in 1, f of 1 is 3, which means if I come back here, this f of 1 is 3.
So it's 6 plus 3 equals 9.
Exactly, yeah. So you're going a little bit ahead of us, but let's go ahead and do that now. This is now going to be 2 times f of 1 is 3 plus 3. That was the first thing. And then I'm going to multiply that by g prime of 1. G prime of 1 is over here. It's 4. And then I'm going to copy down the plus sign. I'm going to copy down 1 plus g of 1. G of 1 is negative 3. Negative 3. That's going to be all times 2 times f prime of x, f prime of 1 in this case. F prime of 1 is negative 2.
Wait, isn't that? Wait.
So I've now used the table to rewrite my yellow equation into my black equation. And I'm going to go up now because I'm running out of room. So if I go up, and then Gio's already started to do these steps, 2 times 3 is 6, 6 plus 3 is 9, so 9 times 4 plus 1 plus negative 3 is negative 2 times negative 4. Simplifying one more step, keep going up and up. 9 times 4 is 36, plus 8, 36 plus 8 is 44. Correct answer is D.
That was my second option.
Okay. I should point out I'm going to be putting a table, but not the same table problem. I know for Geo's has a strategy. Well, I keep recycling the same problems. No, I'm doing a different problem on the AP test. Know how to do these types of table problems. All right. Number 33. I have x squared and e of x. I'm taking the derivative. What rule am I going to be using?
Quotient.
Quotient is a fraction, so
Chain rule.
you're always using chain rule, which is Dowder times dinner.
Okay.
This is the product rule. I'm using product rule because I have two functions that are being multiplied together. Generally speaking, if I ever see two variables, I'm going to be using product rule. I see a variable, I see another variable. And I'm talking about on one side, right? If I see two variables on one side of the equal sign, I'm going to be using product rule. Product rule again, anyone? Plus 2d1, thank you. So 1, I'm going to call this 1, this 2. So 1 is x squared. d2, what's the derivative of e to the x? What's Dowder of e to the x? It's the same, e to the x. What's dinner of e to the x? Always check your dinner.
1.
Dinner's 1, so I don't have to worry about it. Always check your dinner every single time. Plus 2. 2 is e to the x. And then d1, the derivative of x squared. Someone aside from Gio, because Gio's killing it right now. There it is, times 2x. And I need to simplify that. Notice that I can factor out an x and I can factor out an e, because each of these has an x, an e to the x, and e to the x. So I can factor out an x, e to the x. So this is going to be rewritten as x, e to the x. And what's left over? Well, if I get rid of an x, I'm still left with one of them, because there are two of them. And when I get rid of an e to the x, there's nothing left. All right, so plus. If I get rid of an e to the x and an x, I'm left with a 2, so x plus 2. And there's the answer, C. On to number 34. So, it's not asking for the equation of a tangent, which might confuse you. I'm just talking about the slope of the line tangent. That's asking for the derivative. It's another way of saying, hey, what's the derivative? And you guys are like in that nice spot where I've only learned how to take the derivative, and if I'm doing a calculus question, it must be asking, how do I take the derivative? Or some sort of continuity test, something like that. So if you don't know what to do, and you're doing something in terms of calculus for this final, assume you're doing the derivative. There's a very, very good chance that's what I'm asking for. So take the derivative of natural log of x over 2. Again, natural log, you assume it's 1 over, or the coefficient over this x over 2. So the derivative is 1 over x over 2. That's the Dowder. Dowder is 1 over x over 2. I need to multiply by the dinner. Well, before I take the derivative of the inner again is just this x over 2, I need to get rid of the fraction. Actually, it's not really a fraction, is it? It's really, that's the same thing as 1/2 times x. There's not really a fraction. The fraction is a coefficient. I only care when I have a fraction in terms of the variable being the denominator. I'm okay. So what is dinner? What's 1/2 of x, and then take the derivative of that? Half of derivative of x. Someone. Derivative of x.
Negative 1/2.
Not negative 1/2.
2.
What is the derivative of x? Someone.
Oh, 1.
1. So it's half of 1. Half of 1 is a half. Or 0.5, as Gio said. So I now have done Dowder times dinner. I need to now change this into a correct form. So again, if you don't know how to flip these correctly, you can think of this as 1 divided by x over 2. So it's a keep, change, flip. Keep, change, flip. 1 times anything is anything. So the correct answer is 2 over x times 1/2. So I'm going to come over here and say this is now 2 over x. This is equal to 2 over x times 1/2. And notice that the half on the top, or the 2 on the top and the bottom are going to cancel out. The correct answer is 1 over x, but I need to plug in x is equal to 4. So if it was equal to 1 over x, it's 1/4. All right, we are on our final side of our page. This is the last thing that you're doing. It is, isn't it?
Oh, no, yeah, you're right.
We're on the very, very back. And what time do we get out of here today? Out of here at 11:30. We got 13 minutes. We're going to finish this whole packet today.
After you finish, can you put risk?
As long as you have no missing assignments, then yes. All right, so this one. It's asking for h prime of 3. So I'm going to plug in 3 after I find the derivative of h. Well, the derivative of h, I'm going to have to do quotient rule, a division. So quotient rule. Who's got it?
Is that the low
Low D high.
Low D high plus
minus?
It's always minus for this one. Yep, minus
high D low over low low low.
all over low, 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 low. No, it's just low, low, just 2. All right, so that means I need a derivative of the top. I need an f prime. I need an f. So I have a d high and a high. That means I need an f and an f prime. So I'm essentially searching for what is f prime of 3, f of 3, g prime of 3, g of 3. So I'm going to come up here and do some scratch work before I do too much. I need to find what is f of 3. I also need to find what is f prime of 3. F prime of 3. I need to find g of 3, and I need to find g prime of 3. Essentially, these left-hand side, and Gio can help us out here.
What?
Ooh, that looks really nice.
Oh yeah, this is what I'm supposed to do?
Yeah.
Okay.
So, I was expecting to do it wrong.
What do you want me to do with it then?
Can you post it up here in the top left corner? Top left corner of the cabinets.
There?
Yes, please. It might have to hang off, that's fine. On the left-hand side, am I asking for heights or slopes, Gio?
Slow.
This one doesn't work so well, so you have to push really hard. Not quite, Gio. Heights, yep. And everyone else, therefore, this one must be asking for the slope. So what is the height of f of 3, or height of at 3 of f? So on this function f, so there it is. At 3, my height is 1. So I come back over here and say that's 1. What about g? If I look on this function g, if I look at 3, the height is 3. So I come back over here and say that's 3. Perfect. Yep, thank you. Now I'm looking for the slope at 3. So the slope at this point. Well, at this point, notice I'm going down 1, right 3. So I say, I say down 1, right 3, negative 1/3. You always go up and down first, right? Your slope is always your rise over your run, or your delta y over your delta x. And then this is saying, what is your slope at 3? Well, at this point 3 was my slope. My slope is, I go right 1, up 1. Right 1, or sorry, up 1, right 1. 1 over 1, that's just 1. All right, so we have all of these points. So I'm going to consider, I can even write their alternative names. F of 3 is technically the high, the top, right? F prime of 3 is the derivative of the high. G of 3 is the low, and then therefore the derivative of the low, d low, is g prime of 3. So I now know that high is 1. I'm going to come down here and fill in my formula. So coming down here, low. Low, right here, is 3. So low is 3. Multiply that by d high. D high is negative 1/3. Minus high is 1. D low is 1. All of that's going to be divided by low, low, and low squared is 3 squared. And I can simplify. When I simplify, 3 times negative 1/3 is negative 1, minus 1, all divided by 9. That's going to be negative 2/9. So come back over here. The answer is negative 2/9. Correct answer is A. All right, we're doing good. That was a long question. We're on to number 36. This one, I see an x and another x. Chris, what rule are we going to be using? If I see two variables and they're being multiplied together, you can either list the rule or say the name of the rule. Anything. I'll take anything.
Does it start with a P?
It does start with P.
That's all I know.
Product rule. What is product rule, Chris? 1. 1d2, yes, keep going. Is it plus or minus?
Plus
Plus, keep going.
2d1.
There it is. Chris has our product rule. I'm going to consider 1 to be x plus 1 quantity squared, and I'm going to consider 2 to be cosine of x. So 1, just list it again. Whoops. X minus 1 quantity squared. Then I list the derivative of cosine, which is negative sign. Again, C stands for change the sign to a negative. Plus 2. 2 is just cosine of x. I need to multiply that by d1. The derivative of 1, that's powerhouse. This 2 is going to come down in front. That's going to be the quantity of x minus 1, now to the power of 1. That was the doubter. Then I have to do the dinner. Here's the inner. The derivative of that inner is 1. Okay, that means I didn't have to do it in this case. Or I could say times 1 if you want to be very... That is being pedantic, not precise in that case. So from here, I'm going to plug in 0. Plug in as soon as you can. So I'm going to say now 0 minus 1 quantity squared. I should have put x there. Times the quantity of negative sine of 0 plus cosine of 0 times 2 times 0 minus 1. All right, so 0 minus 1 is negative 1. Negative 1 squared is 1. So just it's being multiplied by something else, so ignore it. Sine of 0 is... Anyone? Sine of 0? Good guess, but no. Sine of 0 is 0. Good. So I have 1 times 0, so 0. So all of this is now gone, right? This is all 0. Sine of 0 is 0. And that's going to be adding, so it's, I guess I can say 1 times 0. Plus cosine of 0. What's cosine of 0? 1. Yeah, again, where's 0? 0 is out to the right. Cosine is asking for the x-coordinate. What's the x-coordinate on the unit circle all the way out to the far right? Just 1. And then this is going to be 1 times 0 minus 1 is negative 1. Negative 1 times 2 is negative 2. So 1 times negative 2 is negative 2. And there's my final answer. The correct answer is A. And my last question on this entire packet. I have a variable and a variable with a division, which means I'm using what rule? Either list the rule or give me the name of the rule. Someone, anyone. Excuse me. Anyone, please. Yes, quotient rule. And quotient rule. Someone else, give me quotient rule now. Low. Minus high, D low, all over, low, low. You have to have those guys memorized. Again, you have a note card for the final. You have a 8.5 by 11 sheet of paper, front side only, or you can cut in half and use both sides. Here we go. Low. Low is x squared plus 1. There it is. And then D high, the derivative of the top, that's just 1. So I'll say times 1. Minus high. High is this x plus 3. X plus 3. That quantity times the derivative of low, the derivative of the bottom, the derivative of the denominator. That's going to be 2x. And that's all going to be divided by the bottom squared. So x squared plus 1 quantity squared. All right, when I do that, I'm plugging in negative 2 now. So I'm now going to have negative 2 quantity squared plus 1. There it is, plus 1. All of this is going to be minus, and I'm plugging in negative 2. So negative 2 plus 3 times 2 times negative 2. And that's all going to be divided by negative 2 quantity squared plus 1. That entire quantity squared. All right. Here we go. Negative 2 squared is 4. 4 plus 1 is 5. So I have 5 in the top left. Minus. All right. I have negative 2 plus 3 is 1. So 1, this is just 1. 1 times whatever this is whatever this is. 2 times negative 2 is negative 4, so negative 4. I have a double negative. That's probably the most confused step here. This entire thing was negative 4, so minus a negative 4. All divided by. Negative 2 squared is 4. 4 plus 1 is 5. 5 squared is 25. The answer is 9 over 25. The correct answer is E. And that concludes our practice final. So on Monday, when we come back before the day of our final, what we're going to be doing is just working on any missing assignments, reworking on any of these problems from the practice final that were confusing, asking for help. We have to be doing some sort of math assignment on Monday. And then when is our final again? Our final is Tuesday at 10:30, so it's in the second slot.